it's cut off on half of your screen.
Is that blinking blue, green?
Yeah.
Like, there's the way to your right?
Yeah. This right here?
Yeah.
Oh, okay.
Oh,
How's
oh,
that?
yeah. That much.
It's only
Okay.
so much
Only have
space
that
you
window.
take.
Oh, I see. Okay, well, I will try to put it in the middle here. Yeah, that's because of the... All right, here's what we do. We get it aligned. And for those of you who are listening on the recording, what I'm doing is I'm getting the alignment of the screen put up here. So welcome to 4670. We're here in week 14. We're going to start going over lab 4. So this lab is, I don't want to say it's really straightforward, but a lot of it you have done in previously in lab 3 and lab 1, and setting, routing up and ACLs, things of that nature. The big thing is going to be taking a lot of what you've learned already in the iOS portion and putting it in the ASA. Okay, now if you listen to lecture the last 2 weeks when I've gone over the ASA, you have a kind of an understanding of objects, object groups, how ACLs work, security levels, named interfaces, and everything else. If you have not listened to the lecture, and they're not terribly long, they're about maybe 20-30 minutes, listen to them this weekend. Okay, it will give you a little bit of background knowledge information. So I have started Packet Tracer, and what I'm going to do is look at me, what I'm going to do is I'm going to mimic this infrastructure here with the 2 routers, the ASA, and a couple of switches. Okay, so real quick, I'm going to go down here to my routers, and I'm just going to pick a, say, 2911, and a 2911, and I'm going to come over here to an ASA, and oh, well, it looks like we have a 5506, which is good. This may be a little new. I might be winging this here a little bit because in older versions of Packet Tracer, we've not had a 5506. We've had a 5505. So I'm intrigued. I'm excited now. Great. And I need a couple of switches. Both of the switches are coming off of the ASA. So move that up a little bit, move that up a little bit. Let's go over to the switches, and we're just going to get 2 2960s headed off of these guys. So one there off the DMZ, one off of the inside interface. The rest of, close that real quick. The rest of the topology, if you want to create servers and put them in there to where they're pingable, and you can set up services on them like this, do so. Don't think you can't. But for the purposes of being expedient, I'm going to go ahead and forego that, and maybe I'll do a second recording that shows how to do that here this weekend or in the near future. So be on the lookout for that. Okay, so with that, let's go ahead and start getting everything connected up. And most of it's going to be, I'm going to need a crossover cable here to go between the routers, so gigabit 00 to gigabit 00, and then everything else is going to be pretty much straight through. So gigabit 01 to 11 and 12 to, doesn't matter, just one of those over there, and same thing here, 13 to this switch. Let's put it on 01. All right, pretty simple, pretty straightforward. Let's go ahead and get into these, and that's kind of hard to see, but they should be turned on. Go to CLI, yeah, it's turned on. To get into it, if you just do enable, there should be no password, just hit enter and you're into the interface. All right, so from here, once you have that topology done, the next step that you're going to want to do is basically IP everything. And unlike the previous lab, there's no trickery in this one where I make you re-IP stuff. It's pretty straightforward. So with this, I made this an Ethernet connection, not a serial connection, so that's okay. Even it says fast Ethernet 01 here and fast Ethernet 00. So I'm going to go ahead and start with router 1. Let me check and make sure which one that is. All right, I need router 02. So router 0, I'm going to rename ISP. All right, that way everything will kind of align. And router 1, I think its host name is R1. So we'll go ahead and fix that real quick. R1, oops, there we go. And then the ASA is just FW1. So let's go ahead and just do FW1 and hostname FW1. All right, now everything will kind of look the same as we're dealing with it. The switches, we don't really need to worry about them. There's not any configuration that has to be done excuse me, on the switches at this time. So we're just going to concentrate on the 2 routers and the ASA. All right, so R1, let's go back to the component here. So I did 0, 0 to the ISP. Actually, let me start with the ISP. I apologize. I got a little ahead of myself. So the ISP, which is at the top of the chain here, I connected the 0, 0 interface, this one right there, to R1. So let me go ahead and go into int g0/0. Let me give it an IP of 204.184.21.33 and a 30-bit subnet mask, and turn it on. So basically what I did there is I just gave it this IP address, and then I did the no shut to bring the interface up. Okay? All right. I'm going to exit out of the interface. Now the other thing that I have to do with the ISP is I need to be able to see these routes on the inside of the domain. So I can see this network. I can't see this network. I cannot see this network. I cannot see this network. And I cannot see this 192 network over there. So to set it up, if we look at the lab, configure all equipment with host names depicted in the diagram. Did that in the tab, the config tab. Configure all equipment with the IP addressing depicted in the diagram. We're going to do that as we go through each individual device. No routing protocols are used for this lab, so ensure that you have the proper static routes for all devices. So, can't use EIGRP, can't use OSPF, can't use RIP. We've got to do everything static routing. So this is a good exercise because you get really good at setting up static routes really quick. So, understanding that I need to give visibility to this router to all these networks, I'm going to use the IP route command. All right, so if the ISP router needs to see this route right here, I've got to tell it that route exists with the 204.184.21.28, and it's a 30-bit subnet mask. Okay, that's from the CIDR right there. And then the last part of your static route is, well, what's the next hop? The next hop is going to be R1's interface that faces me, 204.184.21.34. Right, and that's it. Okay, so basically what this command says is to get to this network right here, you've got to go through this interface right here. That's basically how the static route works in iOS. All right, so let's do that with the 134 network. Same thing, IP route, this time 134.68.123.0 and /26 is, what is it?
192.
192. Very good, very good. And the next hop is still the same, 204.184.21.34. Okay? Now we have to do the same thing, but this time with this 192 network over here. And it's a /26 as well. So all I'm going to do is I hit the up arrow. I'm just going to change the network. 192.168.0.0. Okay? Now, I don't have to do that because it's going to be NATed. This network here is actually going to be this network here. If you do it for the purposes of connectivity, that's fine. Okay? If you don't do it, that's fine because it's going to be a NAT anyway. No big deal. So hit enter here if you want to. Don't want to, doesn't matter. I will not take off points for it. So I'm just going to leave that out. And then the same thing with the TIN network. So typically, the TIN network, we're going to have a PAT address of the interface later on in the lab. I don't need to have this here. But if I want to manage this router through AAA or anything like that, I might need to NAT the private IP. So for the purposes of this interior network, all right, I'm going to put that route in there. Now I'll still have security through the firewall with ACLs and NAT and everything else, but I still need to have the ISP have that route. I could need the ISP to have that route. Definitely R1 needs to have it. So just IP route 10.0.0.0, 255.255.255.0. and 204.184.21.34. Okay, and that's basically all you have to do for the ISP. All right, so I'm going to close that out. Now on R1, we have a little bit more to do. So if I go into int G00, which faces my ISP, I give it an IP address of 204.184.21.34. 30-bit subnet mask and no shut. Basically, I just gave it this IP address right here. It's up. Now, to test that if you want to, you can exit out or do the do command and ping its neighbor, the .33. Okay. And you should eventually get bangs, and now you know that you have connectivity. Perfect. All right, now let's connect to the int G01 and connect up to the ASA. So IP add 204.184.21.29. Again, 30-bit mask. All right. And then for the routing on this guy on R1, I don't need to have I do need to have a route to that 192 address. So IP route 192.168.0.0. And the next hop is 204.184.21.30, which is the IP that's going to be on the outside of the ASA. Same thing with the TIN network. But it's a class C, so that's going to be .0. And this command here will give me connectivity to the inside network. Okay? I also need to tell it that the 134 network is attached to the ASA. So IP up arrow twice because that had the same subnet, the same gateway. I just need to correct the public IP 134.68.123.0/26. Same gateway. enter. So that command gives me access to the NAT that I'm going to set up on the ASA. All right. And that's it for now for connectivity, routing, etc. on the R1. The ASA, now this is where we get into a little bit of fun, I guess you would say. We have 3 interfaces to configure. Okay, so let's just do a real quick look here and do a show run. So we have a couple of interfaces that are already set up. We have one that's the inside, 1.1 is the inside, 1.2 is the outside, and nothing else is set up. They already have a security level. One of them has an IP address, which we need to change. The outside has a DHCP, which we need to change, okay, because it's looking for a DHCP address. So we're going to change that. And there's some other configuration in the ASA, I would bet. I take that back. They do not have DHCP services up and running on this thing. Okay. Okay, that actually makes things a lot easier. All right, so let's go ahead and change gigabit 1.1, which is the inside address, I believe. Yep. Oh, we need to make it gigabit 1.1. Let's go back to our topology and see what we have here. So gigabit 1.1 doesn't say what it is set up and pointed to. All right. So 1.2 is with him. So 1.1 is actually my outside and 1.3 is my inside. Okay, so it's a little bit different. So 1.1 is the outside, 1.2 is the DMZ, and 1.3 is the inside. Not a problem. We're going to fix it all. So we're going to do a int g1/1. No IP add. Take out the IP address. We're going to do a no name inf. We're going to go to int g1/2 and do the same thing. No IP add. No name inf. Because we need to take out the outside naming on that one. That's why we had to do that. We do a show run, and you can do a show run. You don't have to do anything there. Oh, it didn't do it. No IP add DHCP. There we go. There we go. Perfect, 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 perfect. So now it's kind of just straight plain Jane. They're up and running. So let's go back to int 1/1, which is the outside interface, and give it an IP address of 204.184.21.30. 30-bit subnet mask. Let's do a name inf outside, and you'll notice by default it will give it a security level of 0, which is what you want. You want to have, this is just a de facto command that Cisco's put in there. Any interface that is named outside is going to have automatically a security level set to 0, so you don't have to worry about it. Conversely, if we go to int g1/3, which is the inside interface, we do the same thing. It'll come up with a security level of 100. We'll get to that in a second. Let's go to int 1/2, int g1/2, and do a no IP add 192.168.0.1. And it is a 26-bit subnet mask, 192. Name inf DMZ. And for the sec level here, notice that when I did a name inf, because it wasn't inside or outside, it didn't give me a security level. So what the security level, remember from the lecture, if you guys watched it, it's like your zoning. All right, so I can send traffic from a higher security zone to a lower security zone without having to pass an ACL, but I cannot do that from a lower security zone into a higher security zone. I have to have an inspection element, i.e. an ACL. So I'm just going to go ahead and make this sec level 50, put it right square in the middle. That's perfectly fine. And if I do a show run, you see that there's my, oh, I did not put the IP on G11. Well, that's weird. Yeah. Okay, so I missed that somehow. So I have the proper IP address on G11 and G12. Let's go into G13 and do the inside address. IP add 10.0.0.1, 24-bit. No shut. Name inf inside. And you'll notice that when I do name inf inside, it sets it to 100 by default. So let's just take a quick little look here. And I have all three of these interfaces set up now. They're all running. They are all working good. They all have the right IP address. They have the right names, the right security levels. So we're here at, we've configured the IP addressing. We've configured the routing. Oh, to set the route, and I forgot one thing. Going back to R1, I forgot to set a default route. I need to set a default route on R1 that points to the ISP. So I'll finish up the routing here, and we'll call it a day for now, and I'll do a second recording here and post it up as well. So this will be part 1. So for this, I'm going to config T, IP route, similar to what you did in previous labs, all zeros route. And the gateway. The gateway for, again, I'm on R1, is the ISP's IP, 204.184.21.33. That IP address right there. All right. Now, I have to do the same thing on Firewall 1. Now, Firewall 1 already knows pretty much all the different routes. It's connected to everything. So I don't really have to do a lot of routing, but if I want to get to the world, I want to get to the internet, I'd need to have a default route. So routing in a firewall is slightly different. So instead of the IP route command, it's more like Linux. It's just route. All right. You have to then tell it what interface you're leaving. So I'm leaving the outside interface. Route outside, all zeros. And then your gateway, which in this case is going to be the interface of R1, 204.184.21.29. Okay. That sink in there for a second. What did I do wrong? Oh, you know what? I put the outside. I'm thinking too much in Linux terms. I think it's that space outside. All right. Why are you giving me problems here? I don't have an outside interface. Interesting. Int G1/1. Name inf outside. Okay. This thing seems a little buggy. There we go. Perfect. I didn't have the interface name, so it wouldn't accept the route. So that sets up the routing. That sets up the IP addresses. We're basically through 1, 2, and 3. I have about, I can finish up 4 through 12 on the next recording. So we'll handle that. Hopefully you can get to this point. I'll have the second recording up here, hopefully within the next day or so. So until then, this is Professor Brown signing off, and we'll see you around.